Hey guys, my name is Katie and I am a PTA. I know a lot of you student PTAs are getting ready to take your board exam in July, and some of you in the middle of your programs might be struggling with online learning right now. So I wanted to create a few videos with some important concepts that will hopefully help at least a few people understand these things a little bit better. So today's topic, as you can see, is the convex-concave rule, which is super important to have down when you learn your joint mobilizations later and in general in your career as a PTA. This is not going to be a concept that goes away, so it's always good to have a solid understanding early on. So first of all, let's go over the terms convex and concave in case we don't remember clearly from all the way back in elementary school geometry. A concave shape is one that has a surface that curves inward. A convex shape is its opposite, a shape with a surface that curves outward. The easy way to remember, concave surfaces cave inward. And the major joints of the body have a convex and a concave component. That's why they fit together so well like puzzle pieces. The convex-concave rule of joint arthrokinematics states that in joints where convex surfaces are moving on concave surfaces, rolling and gliding take place in opposite directions. In joints where a concave surface is moving on a convex surface, rolling and gliding occur in the same direction. So let's go over exactly what this means. For this, we are going to use the shoulder and knee joints as examples. So here we have the scapula with the concave component of the shoulder joint, the glenoid fossa. And you can see how well the convex surface of the humerus fits right in there. Now let's talk about what rolling actually means. Rolling is the large component of joint motion. So if our shoulder here abducts, the humerus is rolling upward. I prefer to use the term sweeping. If the humerus is sweeping upward, because rolling takes place in the direction the bone is moving, abduction means the humerus as a whole is moving upward or rolling upward. Now watch what would happen if rolling was the only motion happening within the joint. The humerus rolls or sweeps upward and hits the roof of the acromion. Ouch. So, in order for the humerus to stay nice and safe within the glenoid fossa, the humerus joint surface must also glide downward while rolling upward. Do you see how those surfaces are interacting? Rolling, or sweeping, is happening in an upward direction, and gliding, the smaller component of joint motion, is happening in a downward direction. So to reiterate, so we're super clear before we move on, the convex part of the joint, the humerus, is rolling upward while gliding downward on the concave surface of the glenoid fossa, opposite directions, as our rule states. And this is the case for all other motions at the shoulder joint as well, not just abduction. Now let's switch it up and look at the flip side of this rule, and we will use the knee for our example here. So looking at the shape of the two joint surfaces here, when the knee flexes and extends in open chain positions, it is a concave tibial plateau moving on the convex surface of the distal femur. So let's extend our knee here. Look what's happening within the joint. The tibia rolls or sweeps upward on the femur, and its joint surface glides upward as well. Rolling and gliding are happening in the same direction because the concave tibia is rolling on the convex femur. So guys, if you have this rule down, you just have to think of the shape of each joint surface and determine which surface is moving. And for me, when I was in school, it was super helpful to draw pictures of these things and how they're happening to really get it to stick in my mind. And also feel free to drop any questions you still have in the comments. I hope that at least a few people have found this useful, and until next time, happy studying.